Alright guys, before moving on to the next part of the lecture, let me give you some exercises that we're going to also solve in the class. So let's do exercise number 2. Alright, consider this differential equation. The second derivative of x equals 0. Function f of x is defined on the domain x belonging to 0 and 1. And the boundary conditions are as follows. F at 0 is equal to 0 and f prime at 1 is equal to 2. Alright, so what I would like you to do is to solve this differential equation problem just like how we did it before. You write out the differential equation, take indefinite integral from both sides until you end up with f of x. Then you have the family of solutions. Afterwards, you can use these two equations, the boundary conditions, to find the solution. I would like you to plot the solution on a plot such as this. So x would be on the horizontal axis and f of x would be on the vertical. So you start from 0 all the way to 1 and plot the solution, whatever it looks like. Alright, that was exercise number 2. Now let's do exercise number 3. Now this time consider a fourth order differential equation. So we'll have fourth derivative of f equals 0, and this time f is defined on a domain from which starts from 1 and goes all the way to 2. Alright, and the boundary conditions are as follows. So we'll have f prime at 1 at the very beginning equals to 0. The third derivative of f at 1 equals to 0. F at 2 equals to 2. And f prime at 2 equals 0. So this is the previous one was second order, this one is fourth order, but essentially you gotta do the same thing. Write it out, take the indefinite integral from both sides until you end up with f of x. And then you have the family of solution. Insert that family to each one of these equations here, which are the boundary conditions, to find the unknown constants and essentially the solution. Alright, so what I would like you guys to do is also find the solution. Oh, by the way, let's name these functions g, so that it's different from the previous exercise. So everything is g in here. Alright, so I would like you to find g and plot it, let's say, on the same diagram that we did before, but note that g starts from 1 to 2, so f was from 0 to 1, by the way, so it's either f or g. So f starts from 0 to 1, so you draw f, whatever it looks like, I don't know, I'm just going to draw something. And so this would be f, and I'll draw g right on here too. So g starts from 1, goes all the way to 2, so g would look like something like this, or whatever it looks like. It has other shapes. Okay, so plot them together. So from 0 to 1 would be f of x, and 1 to 2 would be g of x. Okay, now let's also take a look at a more complex exercise. So these two were pretty simple. You could do it the way that we did in the class. Let me introduce another exercise which is a little bit more complicated. Exercise number 4. So now let's take a look at it. Let's just dive right into it. Let's say we have two domains. X belonging to 0 and 1. This is domain number 1. And we have another one, X belonging to 1 to 2. Right? On this domain, we have second derivative of x equals 0, just like the previous example. And on this guy, we have fourth derivative of g equals 0. Okay, up until here, it just looks like the previous example. The domains are the same as the previous example, and the differential equations are also the same as previous examples. Okay, now let's take a look at boundary conditions. That's where the funky stuff come in. Okay, now the boundary condition, let's consider the boundary condition for this guy as follows. F of 0 equals 0. Okay, that's one boundary condition. Let's consider the boundary condition of this guy. G prime of 1 equals 0, G at 2 equals 2, and G prime at 2 equals 0. Okay, up until now, it kind of looks like the previous examples too. So the boundary conditions are kind of the same. But the different thing comes in here. There are something which we call it matching condition. It's like it tells us that there is a relationship between these two functions, f and g, at the location where they meet. You see here the boundary of this guy is from 0 to 1, including 1. The boundary of this guy, the domain of this guy, and also the domain of this guy. The domain starts from 1 to 2, including 1. So here you can see that 1s are common. So it makes sense that these two functions should have a relationship with one another at this location 1. So let's define that relationship. Let's say that the relationship is as follows. I would say that the first derivative of f at 1, at here, the first derivative, is equal to the third derivative of g at 1. Okay, that's 1. There is another thing. I would say that f at 1 is simply equal to g at 1. The values are the same. So now let's take a look at it. When you solve this differential equation, you take indefinite integral for 2 times, so you will essentially end up with 2 unknown constants. You take indefinite integral for 4 times, here you will end up with 4 unknown constants. Here you will have 1, 2, 3, 4 differential equations. 4 equations, but there were 6 unknowns combined. Now I have given you 2 more equations so that you can find out the 2 remaining constants too. Now, when you found f and g, solve this differential equation, these two, for f and g, and also plot them on the same way that you did it before for the previous example. X and from 0 to 1, plot f, whatever it looks like. I'm just going to draw something so you know what goes where. And from 1 to 2, plot g. Okay, and this one is just f of x and g of x. Okay, so do that and just take a look at how this one and the previous one differs. Okay. Alright, we'll solve this in class.